Who was MC Escher? Maurice Cornelis Escher was born in Holland in 1892. A graphic artist, now internationally renowned, Escher manipulated the geometry and logic of space in order to achieve astounding effects with his work. But he wasn't a mathematician. So why are we doing what? Are you kidding me? Why are we doing a freaking math project on an artist? Why couldn't we pick someone like Euler or Newton or something? You know what? Why are we even doing a math project? We should have voted for the final. I could have aced that shit.
Sorry about that. I didn't get much sleep last night. But anyway, as it turns out, even though Escher wasn't a mathematician, he seemed to have a knack for geometry. In particular, he was really into these regular three-dimensional solids called polyhedrons. Most of the time, he makes a polyhedron obvious, but a few times he'll just slip it into a drawing as a background detail. Only 5 polyhedra have exactly similar polygonal faces. These are the platonic solids. They are the tetrahedron with 4 triangular faces, the cube with 6 square faces, the octahedron with 8 triangular faces, the dodecahedron with 12 pentagonal faces, and the icosahedron with 20 triangular faces. Escher messed around with these platonic solids, intersecting them, stellating them, and manipulating them to make beautiful images. And he would add his own artistic flair on top, even going so far as to draw chameleons in the middle of a big polyhedron, as if to say,
"Hey, listen!"
Escher also messed around with the overall geometry or shape of space. He was into the visual part of topology, which studied how space could be bent and stretched without tearing. He liked the Mobius strip, which is a strip that only has one side and one edge. You could make your own strip by cutting out a strip of paper, giving it a half twist, and gluing or taping the 2 ends together. At first glance, it doesn't seem that special. But after tracing the path of the ants in Escher's Mobius strip 2, your mind starts to boggle. And speaking of mind-boggling, Escher's most famous works were his so-called impossible structures, which screwed up the logic of space, meaning necessary spatial relations between physical objects. He especially enjoyed the Penrose triangle. You've probably seen it before. It's a triangle that makes no sense as a 3-dimensional object, and pretty much just messes with people's minds when they look at it long enough. Yeah, well, he uses this confusing piece of art to create the optical illusions in many of his works, such as waterfall and ascending and descending. And on top of that, he used light and shadows to confuse concave and convex objects. And he used weird perspectives and vanishing points to turn the entire drawing into a confusing pile of horse crap. I mean, what kind of sadist makes art like that? Does he really enjoy giving people headaches? I mean, seriously? Why did we even research this guy? We could have spent our time studying for a math final. I'm so sick of this. That's it. I'm done. Someone will start reading.
Escher's creativity didn't stop at polyhedrons or impossible structures. If you ask what word comes to mind in Escher's work to any Escher fan, they'd be the first to say tessellations. What is a tessellation, you might ask? A tessellation is any geometric plane that is made up of many smaller polygons, where the plane itself doesn't have any gaps or overlap. A natural occurrence of a tessellation we see in our lives is a honeycomb. See how the hexagons all come together to make the pattern that pops out at you, and that the combs do not overlap or contain gaps in the structure? That and many other examples such as tiles in a bathroom, bricks in a wall, and even snakeskin are natural tessellations we see. Before Escher put his creative genius into making the tessellated art he's famous for, mathematicians claimed that tessellations could only be composed by triangles, squares, or hexagons. But knowing Escher's complex and crazy mind, it wasn't long before Escher decided to break these rules and make his own tessellations without these shapes. He first got the inspiration from the Alhambra tiling from Spain. The tiling may not have the regular shapes like triangles, squares, or hexagons, but Escher was fascinated by the repeating patterns the tiling held. And that fascination soon spawned the unique tessellated art with animals and other lifelike figures Escher would make in the future. To create these tessellations, or metamorphoses he named, Escher relied on distorting shapes and exploiting basic geometric patterns. In development 1, the squares from the outer edge appear to twist inward into the center, and the squares soon transform into the reptiles in the middle. And although this sort of tessellation hasn't been done before, it still fulfills the definition of a tessellation. As you can see, there are no gaps, nor are there overlaps by both the squares on the outside and the lizards in the middle. By using distortion, Escher had no bounds to his creativity. If he was able to make squares into a lizard, there really isn't anything else he couldn't make. Reptiles also portrayed tessellation in a creative and almost surreal manner. The reptiles on the page escape the two-dimensional sheet and walk into 3D space, but then return to the page. The only real tessellation is on the paper, but the painting itself is fun to look at, and Escher made these tessellations what they are, fun to look at. In Sky and Water, this tessellation had no distinct regular shapes whatsoever, but at the same time, you can definitely see the repeating patterns of the bird and the fish. On the upper half, you can see the black birds with the white background, but as you get close to the horizon line, the white background soon becomes a clear image of a fish, while the black birds become the background for the fish. It's trippy for sure, but that's what Escher was known for.
Escher, no stranger to tessellations, took them to the next level. He was determined to illustrate the concept of infinity as accurately as he could, but he wanted to do it in an interesting way. In Square Limit, Escher used fish, and to reflect the concept of infinity, he made the fish shrink as they moved away from the center of the work. As the fish approach the edge, the idea is that they get infinitely small. However, Escher was limited in that he could only show them getting so small that they're just a dot. But I think you get the idea of what he was trying to do. If you haven't realized by now, this guy had a way of incorporating mathematics into his work. In his works illustrating the concept of infinity, he used infinite series and non-Euclidean geometry. The non-Euclidean geometry we'll get to in a bit. As for using infinite series, look at it this way. In Development 2, the lizards were shrunk by a constant magnitude. This means that if the initial figure was shrunk to half its size, then the following figure would be shrunk to half its size, and this would go on infinitely. If this work was a series, it might look like this. Like an infinite geometric series, his figures continued upon each other. Back to the non-Euclidean geometry theme. His circle limit series touches on hyperbolic geometry. It's a bit complex. Euclidean geometry, which deals with stuff in a flat space, says that if there's a line, then through a point is only one parallel line. With hyperbolic geometry, a line can have an endless amount of parallel lines going through the same point. There's something called the Poincaré disk that's used to model hyperbolic geometry in 2D. Escher got into hyperbolic geometry because he was inspired by H.S.M. Coxeter's illustration, which was based off the Poincaré disk. Escher saw this model as another way to illustrate infinity. You can see this here, 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 and here.